Okay, sorry about that. Second interruption. That first one was one daughter who just came out and just started talking to me, and the second one was my other daughter who was having technical issues, couldn't get logged into her class. So anyway, sorry about that. So if we continue on, to get the total length around it, we're going to do 4 times the integral. We're going to go 0 to pi over 2. Okay. And then we're going to do the square root of 9 cosine squared t sine squared of t, that's a squared, dt. And we can go ahead and go through and do this. And actually, I think I might leave this integral for you to try. I think I will. And so what I want you to do is I want you to try this integral. I might give you the next step here, and I'll probably finish writing it in on the notes for you to go look up if you can't get it. But 3 cosine t sine a t dt. And so what I want you to do is go through and you do this one, okay? Finish it up. You're going to have to do some u substitution. It's not a very tough integral, but do u substitution and you'll get it. And see if you get the same thing as me. I'm going to write it in down here like a 6, and then I'll fill in the steps on the note for you to look at so this video can be just about over. All right, so next here, we're going to look at the areas of surfaces of revolution. And so here I'm not even going to do an example problem because this is very similar to something we were doing earlier. We are essentially going to look at this and we're going to say, okay, here is our curve right there. That was not very good. Here is our curve right there. And what we're going to do is we're going to treat it, again, like it's a radius, and we're going to multiply it. We're going to multiply it around and revolve it, just like we did before. So we want to revolve it around the x-axis, which is what you see in the picture. We're going to do 2 pi y, okay? We're going to do the y there, right? 2 pi r is our circumference of a circle, and so we're going to add these all up, and then we're going to revolve it this way, or revolve it this way around this x-axis, and that's going to give us kind of what would look like here. It's kind of hard to see in that picture, but it would almost here on this one give us like a donut where it didn't actually have a hole, or the radius of the inner hole was 0. So it's like a, it's dipped in, but not, there's the hole in the center is not actually there, it has a radius of 0. And then if we wanted to revolve it around the y-axis, you would do 2 pi x and then do the same line integral, just like that. So it's nothing too terribly crazy. Hopefully that makes some sort of kind of physical sense to you, and you can just go through and do those. It's just a matter of adding on that one little extra part right there at the beginning. Okay, that's pretty much it.